Now, next result is, this is very important result. Prove that for a space curve, this is for a space curve, r vector, which is a function of arc length, it satisfies these two conditions. Scalar triple product of this is equal to this values, and scalar triple product of this is equal to this values, right? Now, in this first case, it involves R double dash, R triple dash, and R4 dash. So, as we know that R dash, which is equal to T, unit tangent vector. Now differentiate with respect to S, it will become R double dash, which is equal to T dash. What is the T dash? Which is equal to kappa n vector. So this is by Freenet formula. Now again differentiate this term with respect to S. Now the derivative of this term is, first we take its derivative, then we take the derivative of kappa. So it will be kappa n dash plus kappa dash into n vector. So this is a r triple dash vector. Now substitute the value of n dash, which is equal to tau b minus kappa t, and this kappa dash is same as it is into n vector. Now simplify, we get kappa tau b vector, this vector, minus kappa square t, this vector, and plus kappa dash n vector, this vector. So this is equation number 2. Now again we differentiate this equation with respect to S. So this will be R fourth. Now differentiate, it contains 3 terms. It contains 2 terms. It again contains 2 terms. So first I take 3 terms, k dash tau b. First derivative, kappa tau dash b. So first I take its derivative, then its derivative, and then its derivative. And third term is kappa dash kappa tau b dash, right? Now from this, if we differentiate, so derivative of kappa square, which is equal to 2 kappa kappa dash, this values into t vector, and derivative of t vector, which is equal to kappa square t dash vectors, right? Now from this, kappa double dash n vector plus kappa dash n vector dash, right? So we get these values on differentiate equation number 2 with respect to S. Now from this equations, so these two terms involved b vector, right? This is denoted by circle. So kappa dash tau plus kappa tau dash, these two terms involve b vectors, and these term involve n vector. This is n vector, and this term involve t vector. This, and this. These three terms involve n vectors, and this term involve t vector. Now separating all these values, so this is minus 3k k dash. So this is from this one, minus 2 from this, and minus 1 from minus 1 kk dash, that is from this. So this is by rectangle, denoted by rectangle, and it is again denoted by rectangle. So add these two terms, we get the value in term of t vector. Now in term of b vector, one circle, second circle, and this is a third circle. So what we get? We get 2 kappa dash tau, right? So this is 1, this is 1. So what we get? We get 2 kappa dash tau plus kappa tau dash, that is from this equation. So this is a kappa tau dash, okay, into b vector. Now n vector contains 3 terms. One is this term, and second is, one is this term, second is this term, second is this term, n vector, and third is this term. So this will become a kappa double dash minus kappa q minus kappa tau square into this values. So this will get this equation number 3, right? Now if we get the equation number 3, this is our fourth vector, and its derivative up to fourth derivative. Now this values, now if r double dash vector and r triple dash vector, if we are taking the cross product of these two terms, if we are taking the cross product of these two terms, what we get, now this is r, one is r double dash and second is r triple dash, clear? So this equation r double dash, this is r double dash kappa n vector, and this is r triple dash and this values, clear? Now taking cross product, so n vector with cross product n vector, it will be 0. We get these two terms, one is with b vector, second is with the t vector. Now simplifying, this is one is from with the t vector and second is with the b vector. So what we get? We get this kappa q b vector plus kappa square tau t vector. So this will become this term plus this term. Clear? So this is equation number 4. Now taking the dot product with r fourth derivative. So when we take the dot product, we get this values. Now dot product with same vector is equal to 1, with different vector is equal to 0. So we get only these terms. This is kappa square tau minus 3 kappa kappa dash kappa cube, and this is 2 kappa dash tau plus kappa tau dash. So on simplification, we get this equation. We get this equation. Clear? Now, this can be written in the form of multiply by kappa square and divide by kappa square. So this will become kappa raised to power 5, and this is into this over kappa square. So this is a derivative of tau by kappa, and this is kappa 5. So that is the proof of our first result. On the same line, b dash, this is a b dash, which is equal to minus tau n. Clear? We know that if it is equal to minus tau n, so this is a b dash by Freenet formula. Now again differentiate this. So first derivative of tau, tau dash, then derivative of n, which is n dash. Here it is a tau dash. Clear? Now substitute the value of n dash, which is tau b minus kappa t. Clear? On simplification, we get this values, kappa tau t vector into minus tau dash n vector minus tau square b vector. So this is the value of b double dash. Now again differentiate with respect to s. Clear? So this derivative, now it contains 3 terms, it contains 2 terms, it again contains 2 terms. Now differentiate. So we get these terms with equal to, this is equal to this. From first we get these 3 terms, we get these 2 terms, clear? And then we get these 2 terms, right? On simplification, we get this values. This is into t vector, and this into b vector, and this into n vector, clear? So we get the value of b triple dash. Now scalar triple product of b dash, b double dash and b triple dash. Now substitute the value of vector coefficient of t, n and b. Clear? Here it is coefficient of t vector, here it is coefficient of n vector, here it is coefficient of uh, t, n and b vectors. So first row give the value of b dash, second row give the value of b double dash, right? Third row give the value of b triple dash. Now taking the determinant, so we simplify this determinant, again we get this equation. Now in to form in this form, clear? So we multiply by tau square and divide by tau square, so we get this values. tau raised to power 5 into d by ds into kappa by tau. So this is very important result for university examinations. Now, again, it is again important for university examination. So, in order to solve this kind of differential equation, clear? So, this is a differential equation. Our purpose is to solve this. Clear? Now, this is from the r dash, which is equal to t vector. Again, differentiate t dash, which is kappa n. Now, from this, our purpose is to find this. What is it? Is a rho r dash. Clear? So, what is the value of rho r dash? Rho kappa n. We know that rho is the reciprocal of kappa. The kappa is reciprocal of n. So, these two terms cancel to each other. We get this is n vector. Now, next step is differentiate with respect to s. Now, differentiate with respect to s. We get n dash. So what we get? We get tau b minus kappa t. So this is using the Freenet formula. Now what is tau? Which is 1 by sigma. And what is kappa? Which is 1 by rho. So this is value. Now next step is to multiply with sigma. Clear? So if we multiply with sigma, we get these values. This cancel. This sigma by rho. So we get these values. Now what is the next step? Next step is differentiate with respect to s. So we differentiate with respect to s. So this will become b dash. Here it is b dash. And this is a derivative of entire term. So here it is a derivative of entire term. Clear? So what is b dash? B dash is equal to minus tau n by Freenet formula, and this is a derivative. Now we can shift this derivative to left hand side. So when we shift these both term to left hand side, this will become first term, this will become second term, and third term will be plus tau n. Tau can be written in the form of sigma, so which is 1 by sigma into n vector. Clear? So this value, so this is the third term. So what we will get? We get this is first term, this is second term plus third term equal to 0. Clear? So that we want to prove our result. So that is our result. It is very important result for examination, university examination point of view. After that, it is very important curve which is called a helix, or we can also used as cylindrical helix. So what is helix? It is a basically curve on a surface. Now here the surface is cylinder. So what is it? Is a curve which is a curve on a surface. Clear? Of a cylinder. We know that the equation of cylinder, which is of this form. So this is certain. This is not exactly I am able to find the draw the picture of cylinder. So you can imagine just it is of this kind. Clear? This is a cylinder, circular cylinder. Now, what is the aim of curve in the case of helix? That curve cutting the generator with constant angle. So remember this. So angle between curve and generator, if it is a direction of a generator, so angle between curve, this is this is a in the spiral form around this cylinder. Clear? So angle between generator with and curve means tangent to the curve is a constant angle. So that curve is called helix. So that curve is mainly we can see in the Punjab University, that is a student centers. So as we move upward, so we are going through the helix. Now this is upward and downward directions. Now in this case, angle between the tangent to helix and fixed line or generator of cylinder is a constant. So remember that curve is called helix. Now for example, this is a cylinder. If this is a cylinder, so this is in a along x-axis horizontal direction. So we can also find the curve when it is in vertical directions. Now the curve is moving around this, clear? Around this and this and this, clear? So this angle that is a tangent to curve and its generator, that angle is constant, which is written as alpha. So this is a definition of a helix. So remember, so example is the student center of a Punjab University that is near the library. Now this is very important result. A curve is helix. Yeah. So property, we can also say that the property, and also this is a theorem. So if the curve is helix, then remember the kappa by tau ratio is constant. Clear? It is a if and only part. If this result is true, then this result is true. If this result is true, then this result is true. Now let T a unit tangent vector to the helix, clear, and A is a constant vector parallel to the direction of axis, clear. Now the given is the angle between them is constant, that we can take it as alpha. Now this is A vector, which is a direction of, this is T vector, this is B vector, suppose, because it is perpendicular to tangent. Now this angle between A and T vector is alpha. So this is an angle which is equal to alpha angle, which is a constant. Okay? By definition of helix, this is a T dot A, which is magnitude of T into magnitude of A into cosine of angle between them. So because it is unit vector, its value is 1, and it is a vector constant, which is a cos of alpha. So this is magnitude of A vector and cos of alpha. So we get this value. Now differentiate this with respect to S. Now when we differentiate, which is T dash dot A plus T into A dash. Clear? And this is equal to 0. Why 0? Because this term is constant. This term is constant. So derivative of constant term is equal to 0. So this will be 0. If this will be 0, now this A dash is again 0. Why this is 0? Because A vector is a constant vector. So what we get? We get these values. Now substitute the value of T dash. What is T dash? Which is kappa n dot A vector. So this can be written as in this form. So what we get? We get these values. N vector dot A vector. Clear? Now it means this A vector is perpendicular to N vector. So remember this. A vector is perpendicular to N vector. Now A vector lie in a plane containing vector T and B. We know that. And also it is perpendicular to N vector. If also it is perpendicular to N vector, then it is A vector is in a rectifying plane, because it lies between T and B vectors, plane containing and perpendicular to N vector. So this is in a rectifying plane. So as we discussed earlier, if we take, this is a three-dimensional space, this is a three-dimensional space, this vector is T, this vector is T, and this vector is N, and this vector is B. Clear? So this vector is B. So what is this? Is a osculating plane, right? And this is a normal plane. This is B vector, and this is a rectifying plane. So remember this. Clear? So A vector lie in a plane containing T and B vector. So it lies in a rectifying plane. So in this way, then what we get? We get this, they are coplanar. All the threes are lie in one plane. If they are coplanar, then A vector can be expressed as T vector cos alpha, because angle between them is alpha, and angle between them is 90 degree minus alpha. So this is b vector cos 90 minus alpha. So this can be written as t cos alpha plus b sin alpha. Now differentiate with respect to s. So its derivative is 0. Here it is a, because it is a constant. So we get only t dash, right? Here it is constant, we get only p dash. Now substitute the value of t dash kappa n, and it is minus tau n. So what we get? What we get? We get kappa cos alpha minus tau sin alpha into n vector. This term is equal to 0. If this term is 0 and n vector is non-zero, so it means kappa cos alpha minus tau sin alpha, which is equal to 0. So from this we get tan alpha, which is equal to kappa tau. Clear? So which is equal to kappa tau, and this is a constant. So it means kappa by tau is a constant values. Clear? So it is first part. Now converse. Now given kappa tau is constant, suppose it is p. This is a constant values. Then kappa can be written as p tau. P is constant. Now differentiate t dash, which is equal to kappa n vector. Right? What is the value of kappa? P tau into n vector. So this can be written as minus p minus tau p tau n vector. Now this is minus p, and this is by value p dash. This is by Freenet formula. Clear? So this can be written in this form: t dash plus pb dash equal to 0. Now integrating on both sides. So t plus pb vector, which is constant, say it is a vector. Clear? So because it is constant. Now to find the value of angle A and T, then taking dot product with the T vector. So this will be T dot T, and it will be 1, and it is a B dot T. This will be 0, and this is a dot T. Clear? So this will become T dot A, which is equal to 1. So what is 1? 1 is a constant values. So angle mean angle between tangent to the curve and axis of the cylinder, which is a constant. If it is a constant, then by definition the curve is helix. So this is very important result. If curve is helix, then the ratio of kappa by tau is equal to constant. If kappa by tau is constant, then curve is helix. So in order to find the curve is helix in the questions, in the application, just find kappa and tau, then check whether the ratio is constant. If the ratio is constant, then curve is helix. Now, from this, the curve is to be helix if and only if this scalar triple product is 0. Yeah. So this is t dash t double dash t triple dash, which is equal to 0, because it is a because kappa and tau is a constant. Now go to the previous result. If kappa tau is constant, then its derivative is 0. So here we get a relation between these triple product and derivative, I think so, in this video. So that will give, now from this, if kappa tau is 0, if kappa tau is constant, so this derivative is 0, then this term will be 0. Similarly, kappa tau constant, tau by k kappa constant, so this value is 0. So this term is 0. What is this? This is a t dash. This is t double dash. This is a t triple dash. Clear? So from this, using that result in this equation, then we get that this scalar triple product is 0. So remember this, sometime examiner will be asked in this way to find for a helix this scalar triple product is 0. Clear? So all the theories are related to each other. If we go through the entire syllabus and entire theorem, entire definition, then there is no problem to understand mathematics. The problem is to understand mathematics is that when we go to first theorem, then go to ninth theorem, then go to 15 theorems. So that's why we are not able to understand the mathematics. So all the results are related to each other. Now next result is condition. Find the condition that the curve is to be helix when that is a condition. Clear? So how we can find? So this is a equation of curve. Clear? Then find curvature that you already find. Find torsion that that is tau. Then the condition is kappa by tau is constant. Then substitute and find the values. So this values and also use this result. Clear? So you can use this result that taking triple product equal to 0. If taking triple product equal to 0, you can also get the condition. Clear? So this is the way to find the condition. This is this using this result. Okay, if this triple product is 0, then you will get this kind of equations. So just find curvature and torsion. Yeah, just find t dash, t double dash and triple t triple dash. Okay? And taking the scalar triple product equal to 0, then we get the conditions. Now, next theorem, which is very important result, and curvature kappa and torsion tau of a helix. Clear? We already know that are in a constant ratio. Are in a constant ratio to the curvature kappa 1 of the plane of curve obtained by projecting. This is here we used projection. Projecting C on a plane perpendicular to the axis of the cylinder. In other words, this is very important result. Kappa is equal to kappa 1 sine square alpha and tau is equal to kappa. So that we will